Hello, one more time, grade 10s. Let's continue with our statistics. Now, in this video, we're going to focus a lot more on ungrouped data. Remember, the previous video we introduced to you the concept of data. Now, in this video, we're going to focus on ungrouped data and see how we can represent this data. All right, fine. Ungrouped data is a set of values or observations, right? And the data is discrete since the values are distinct or individual values. Right, fine. For example, a set of final exam marks for 30 university students is reflected as an ungrouped data. Right, fine. Another example could be the number of goals scored by Kaizer Chiefs or whatever team. Ungrouped data can be represented in different ways. Three most common ways are frequency tables, bar graphs, and stem and leaf plots, which is what I'm going to dedicate this video to, plotting 1, 2, 3 of the most common ways of representing our ungrouped data when we're collecting it. So we're talking about that discrete data again, that is not grouped. Fine, and when we speak in the following videos about grouped data, you understand the difference. But for now, let's continue. So our first segment there is going to be focusing on frequency tables. So I've already drawn a table template of some sort on the right hand side here. But let's try to understand the question so that we move together. Now I have an example here. The number of different colors of fonts was collected at some school for 12 learners. I've forgotten that. For 12 learners, and recorded as follows. So in this blue box that I put here, I try to record the response that each learner gave us. Right, as we're asking. The first one tells us blue, red, blue, gold, again, like that. So the first one told us blue, the next one told us red, the next one blue, like that. So we have blue, gold, blue, black, until we had asked all 12 of these learners. Right, how would you then represent this data, or how can this data be represented in a frequency table? So what a frequency table usually is in the first column or so, we're going to put what data it is we are studying or recording, and then sometimes we may want to record the number in a tally form, or we just want to record it in a frequency form. So frequency is just the number of times something is occurring or something is appearing. All right, fine. So in this case, we're gonna come and count the number of blue fonts for those 12 learners of ours. Right, fine. So if you come here into the box here, I've tried to circle them again color coded so that you can easily see. Blue, we're looking for blue, so we've got 1, 2, 4, 5 fonts. So that you write it over there for your frequency, that's 5. You may as well start with a tally if you are comfortable with that. Wouldn't be difficult really. So we go 1, 2, 3, 4, 5. There we go. All right, fine. Let's move on to red real quick. Red, we've got 1, 2, 3. So we've got 1, 2, 3 in the tally system, and then the frequency is just the number 3. That's how many red fonts we have. Let's check black. We've got 1, 2. So in the tally system should be 1, 2, and then in the frequency is just that number again of black fonts that we have is just 2. And then gold. How many golden fonts do we have? 1, 2, just like black. So I've got 1, 2, and then in the frequency the number is 2. There we go. So the total time is very important. In fact, it is very important because it tells us how many people we actually surveyed. Let's say we did not specify that 12 learners were surveyed. If we were given data like this, the total of the frequency tells you how many items or data points were studied. All right, cool. So the total of this, if you check out, it should be equal to the number of learners that we studied, which is 12. So let's go. 5 plus 3, you've got 8, plus 2, that's 10, plus another 2, making it 12. So you can also represent that in a tally system. So we go 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, now a 10, and then 1, 1. There we go. That's a frequency table for you. my own example frequency table. Now we can have different kinds of frequency tables talking about different kinds of things, but this is the typical example of how you would draw your frequency table. All right, let's move on to the next one. Over here, I've got a bar graph, a question about a bar graph. Now we want to represent the same kind of information the previous one in a bar graph now. So there are many ways, like we said, of representing data, and the use is therefore to be able to interpret this and maybe come up with a conclusion like which phone is the most favorite, rather which color is the favorite color here for their phone. You would see that the highest appearing, most frequent number there would be that favorable color for their phones, and that's why data handling is important. And which color do learners generally hate? And then you see that around black and gold, maybe they don't like those colors for this particular experiment. So this data can then help if it was a company trying to make more of these different colors, then they would know which color to make more of and which color to make less of. All right, now let's go and try to draw the table. So, I mean the bar graph. To draw a bar graph, we need this information from the frequency, and we need this information from the whatever it is we're studying, so that is color. So our x-axis will be color, the first column. Now y-axis or frequency. We do not use the tally one to draw a bar graph. That will not be practical. So we use these two. So down over here, I've already labeled for you blue, red, black, and gold. So the only thing, and I've also set up a scale there for frequency on the y-axis. All right, there you go. So now what we need is to draw the blue graph, and we need to know how many phones were blue, and this is 5. So let me quickly grab a blue color. Hopefully this one is better. Blue color, and this should be 5. So I need that to get up to here. So my lines, they may not be exactly as straight as you would like, but that would be the bar graph for the blue phone. Okay. Out of the 12 learners we surveyed, we got 5 of those. All right, let's check out red. Red has 3. Red has a frequency of 3. Therefore, I'm gonna come and grab red there. Rather, choose that dark one. Red has 3, so there is 3. Now, be careful. A bar graph should not be joined. If we ask you to draw a bar graph, please do not join the bars. If they are joined, it's now something completely different. It's now called a histogram. And we'll talk about histograms when we go to grouped data. Right, fine. Let's take a look at black. Black has 2, and so does gold. So that should end that one. So we quickly rush there. 2. Black has 2, and also gold. So I know where to stop when I'm drawing. So there's black, bar, ugly, but gets the job done. And then there is your gold bar graph. So this is really basic stuff that you probably would be able to do on your own. Again, this picture kind of a bar graph now would normally have a heading over here. Draw it. You would want to put a heading here of what it is you are drawing. So for my heading, for example, I want to say what is it that we're recording. The heading can talk about, let's say, favorite. Let's say learner's favorite colors. Learner's favorite colors, fonts, or what the case, whatever your heading should be, but it should tell us more about what it is we're seeing here. Sometimes there may be a need for a key. That means if you've got a lot of stuff in there, you might want to draw a key. and your key should be color coded or shaded in a way that reflects what it is that you have here. But in this case, very simple bar graph, and that's it. All right, fine. Again, it helps us to see which one in a way of visual sense. You can see which one is the highest there, that is blue, and you can see which one are the lowest there, gold and black, and then that can give us a much better understanding of what is liked or favored more and what is least favored. Let's go to the next section, which is the stem and leaf plot. Now, you might remember this again from previous grades, but anyways, let's go and talk about it. Now, take a look at this example. Grade 10 learners at some school XYZ wrote a statistics test out of 50. Their results are shown below. So there's a 27 out of 50, 19 out of 50, 33 out of 50, 22 out of 50, 40, 16, blah, blah, blah. Right, fine. What we need to do here is to draw another kind of representation of ungrouped data called a stem and leaf plot for this data. Now, what do you do here? So I've already separated this. On the left hand side, I drew what we call the stem, and then on the right hand side, I wrote leaf. What exactly is the stem? On the left hand side, where you have the stem, please put the leftmost number, right? So for the stem, let's discuss it here. Put the leftmost digit. That's the easiest way of saying it. We can say the highest place value. That's another way of saying it. So for example, if the number 321, the stem would be 3. Hopefully that makes sense. Or for the number 57, the stem would be 5. Hopefully that makes sense. The leftmost digit is your stem, and then these other ones that remain become leaves. Okay, the rest are leaves. Okay, so what we're going to do here, we're going to first say in this data that we have here, right, all of them seem to just be units and tens, units and tens, units and tens. All of them seem to be like that. So that means our stem is going to come from the tens. So these will be our stems, the ones I'm underlining right now. Okay, so now we need to draw our stem and leaf diagram starting with the smallest stem. So check around here and find the smallest stem, the smallest leftmost number. So this one is 2. I see a 1 there. I see a 3, a 2, a 4, a 1, a 4, a 3, a 2, a 2. So the smallest one should be a 1. Now what do? I need some kind of color coding here to help me balance right up. So I've got this one, which has a smaller stem. That one, which has got a stem of 1. So those two have a stem of 1. I can now automatically come here and write 1 for the stem, and then I'm going to add the leaves of these two stems in ascending order. So we need those leaves. The first leaf should be 6, and then the next leaf is 9. So when we are reading this, we know there is 1 6, and then we know there's 1 9. So that is 16, 19. I've already represented the first stem or our left stem there in that diagram. Let's move on to the next stem, which should be 2. So all the data points that I've got a stem of 2. So I've got 1, 2, 3, 4. They have a stem of 2. And I now have to arrange the leaves in ascending order. So I've got 0. The next leaf is 2. And the next leaf is 7. Next one should be 9. That's the next leaf. Right. Then, because I think we've got all of them there captured. Let's try to check the black is not going to give us, this color is going to give us a problem. Let's go with black. Right, I need a stem of threes now. So I have only two stems, two data points with a stem of 3. So we go 3, and then we've got 3, 0, then 3, 3, and that's the end of it. So continuing further, we now have the last information. Let me use this color right here. Okay. So up next, we have got a stem of 4. And again, you see this is pretty much very simple. A stem of 4 has got how many leaves? 2 of them. There's 0. And where's the next one? 4. So in ascending order, that's 0 and 4. So this diagram, in most cases, summarizes, in fact, every time it summarizes your data point like that and arranges it in a way that can easily help us to understand how many people fall within each group in a way or a level. This would be helpful to understand which level most of the learners fell into. Let's say, for example, this way out of 100, I would then know that this is level 1, this is level 2, level 3, whatever the case may be. Right, fine. For the sake of this question, I'm sure now you understand. We've got everyone who has anything less than 20 should be here on stem 1. So I've got 1, 6, 1, 9. Anyone who has at least 20 something is in level number 2 here, rather in the second row, the third row here, which would be 20, 22, 27, and 29. So again, it tells us how many people performed in this general area, how many people performed in that general area. So if we want to understand our performance of these learners, we can then say, oh, most of my learners are here. Most learners seemed to perform around here. We can change that to percentage and understand whether it's a good mark or a bad mark. And then the least learners again seem to be all over here, evenly distributed over the other segments. So yeah, guys, that's it. We've done the stem and leaf plot. We have done in the previous one the bar graph. We've also done the frequency tables. So that's it, guys. Let's meet in the next one. We actually do some measures of central tendency for this ungrouped data, and then we can move to, rather for this ungrouped data, then we can move to group data. All right, see you in the next one. Bye.